Hi guys. Today we're working on absolute value inequalities. So let's think about absolute value inequality. We have the absolute value of x minus 3 is less than or equal to 2. What values of x make this true? So let's try 0. So if I substitute 0 right there for x, I have 0 minus 3 is negative 3. When you evaluate the absolute value of a negative 3, you get 3. Is 3 less than 2? No. So 0 is not it. Let's try 1. 1 minus 3 is negative 2. The absolute value of negative 2 is 2. Is 2 less than or equal to? Well, 2 equals 2. So this one works. Let's try 2. 2 minus 3 is negative 1. Evaluate the absolute value of negative 1. Is 1. Is 1 less than or equal to 2? Yes, 1 is less than 2. Okay. How about 3? 3 minus 3 is 0. The absolute value of 0 is just 0. So is 0 less than 2? Yes. Let's try 4. 4 minus 3 is 1. Absolute value of 1 is 1. 1 is less than 2. Check. 5. 5 minus 3 is 2. 2 is the absolute value of 2. So 2 equals 2. Bam, another one checks. How about 6? 6 minus 3. That's 3. Absolute value of 3. Is that less than 2? No. So I know my boundaries now. So show your work and represent your answer on the graph of the inequality below. So at this point, it's fair to say that all the values between 1 and 6, 1 and 5, 1 and 5 works. All right, so let's create a number line. Doesn't have to be beautiful. So I have 0 right here, 1, 2, 3, 4, 5, and 6. So all the numbers between 1 and 5 are yay okay. So close dot right there, close dot right there. So everything between those numbers would make that inequality true. So write the solution as an inequality. So 1 right there, 5 right there. X is everything in between. And then they're both closed dots. So closed dots right there. How many pieces do we have? So it's just one piece. One piece. How about on this side? Now let's think about this other absolute value, which is very similar to the one we just did, but the inequality sign is now different. So this one was less than or equal to. This one is greater than or equal to. So we're going to have to try the numbers like we did here. So let's start with 0 again. Why not? So 0 minus 3 is negative 3. The absolute value of negative 3 is 3. Is 3 greater than 2 or equal to? Yes. So 0 works. Let's try 1. 1 minus 3 is negative 2. Absolute value of negative 2 is 2. Is 2 greater than or equal to 2? Yes, it is. So 1 works out too. Let's try 2. 2 minus 3 is negative 1. The absolute value of negative 1 is 1. Is 1 greater than or equal to 2? No. 1 is less than 2. So 2 doesn't work out. 3. 3 minus 3 is 0. 0 is not greater than 2. So 3 doesn't work out either. 4. 4 minus 3 is 1. Absolute value of 1 is 1. Is 1 greater than 2? Nope. 5. 5 minus 3 is 2. 2 equals 2. Okay, that one checks. One more just because. 6. 6 minus 3 is 3. The absolute value of 3 is greater. It's positive 3. So 3 is greater than 2. Yes. So all the values that are not, that are less than 1 going here. So all the values less than or equal to 1 or greater than or equal to 5. Those are the values that work. Create a number line. So I have 1 right here, solid dot. All the numbers less than 1, they go this way. 1 right there. And I have 5 right there, greater than goes that way. Okay, so write the solution as an inequality. So I have x is less than or equal to 1, or x is greater than or equal 5. Okay, now notice that we have 2 pieces of inequality right there. So we have 2 pieces. Okay. In words, what does the absolute value inequality represent? So we have, this is the graph of the absolute value of x minus 3, right there. This is f of x. Okay, this line right here, this is the y equals 2 line. Okay, notice how they intersect right there. That's your 1 and that's your 5. That's cute. Okay, so going back to the question, what does the absolute value inequality represent? So the values that are a certain distance from a given value. In this case, the value was 2. Sometimes it's from 0, sometimes it's up there. Okay, so it's that certain distance that we're looking for. Here is how you solve this. Well, going back to the graph, notice how the absolute value function is composed by 2 linear functions. One line, the other line. Notice how they have the same slope, but one is positive slope, the other one is negative slope. Okay, so when you're solving the inequality, as long as your absolute value has been isolated on this side, you're ready to open that into linear inequalities. One, you're going to keep the same way. The other one, you're going to switch the inequality sign and also switch the sign that belongs to the value. Switch the inequality sign and also switch the sign of the number. Okay, now you solve them separately. Minus 5 on both sides. Here you have x is greater than negative 2. That's one part. The other part, minus 5 on both sides, that will give you x is less than negative 8. So the solution, before you write it out, think about what it looks like on the number line. So x is less than negative 8, so it goes all the way toward negative infinity for this one. And for x is greater than negative 2, x will go all the way toward positive infinity on that one. So let's write our solutions in two different ways. One is an inequality, which we already have it right there. And the other one, let's do as a interval notation. So from here, it goes from negative infinity to -8, and then it goes from -2 toward positive infinity, right there. Another one. So fully isolated, right there, the absolute value. So we're ready to separate that into linear inequalities, but just be sure on the second one to switch the inequality sign and switch the sign of the number. Solve them separately. So -7 on both sides. Same here. Now, let's think about before we write the solution for this one. I'm going to sketch the number line right there. So here's my number line. I have -9 right here, but it's going that way, going to the right, that way. And if I have -5 right here, it goes to the left, that way. Okay? So that will give me a one-piece inequality. It will give me a one-piece answer. So how would you write this? Not like that. So the solution to this is -9 is less than or equal to x, less than or equal to -5. If you're writing in interval notation, so -9, -5, they're both with brackets because that's inclusive. Okay, fully isolated there. X minus 1 is greater than or equal to 5. Remember to switch the inequality sign and the sign of the number. So add 1 to both sides. That will give you 6. Also add 1 to both sides. That will give you -4. Think about the number line. X is less than -4, so it's going toward negative infinity. X is greater than or equal to 6, and it's going toward positive infinity. So this answer is good to go. Now, if we're writing this as interval notation, we always have to write that in order. So from negative infinity to -4, that's inclusive. And from 6 toward positive infinity. Either answer is acceptable. Okay, this one. Before I can split that up in two linear inequalities, I have to isolate the absolute value portion of it. So I have to start out by subtracting 1 from both sides. So I have -1 on both sides, that gives me 20. Divide both sides by 4, that leaves me with absolute value of 2x minus 5 is greater than 5. At this point, the only thing I have is the absolute value of 2x minus 5 right here on the left-hand side. Now you're ready to open that in two linear inequalities. So 2x minus 5 is greater than 5. 2x minus 5 is less than -5. Remember to switch that. Okay, add 5 to both sides. That's 10. Divide by 2. That's 5. Add 5 to both sides. That's 0. Divide by 2. Still 0. Okay, think about the number line. X is less than 0, so it's going toward negative infinity. X is greater than 5, so it's going toward positive infinity. So this answer right here is good. I don't have to rewrite that as a one piece like I did on this example right here. And your solution in interval notation, I have, so from negative infinity up to 0, exclusive, and then from 5 toward positive infinity. And I'll come back and I'll come up with another video for the rest of this page.